Questions 12 to 16 in the ACER blue paper. Question 12. For figure 1a, oxygen uptake increases speed because A. Water temperature changed. B. The fish used anaerobic respiration. C. The metabolic rate of the fish changed. And D. Gas exchange occurred at organs other than the gills. So let's have a run through this question. Most important thing to note is that figure 1a involves a graph at a constant water temperature. So that water temperature of 15 degrees Celsius. So as such, we can immediately rule out A because A infers that the water temperature has changed, whilst for figure 1a, the water temperature does not change. So A is incorrect. B, the fish used anaerobic respiration. The fish uses anaerobic respiration past TSS. So that is not true for figure 1a because point M is the point of TSS, and under that there will still be no anaerobic respiration. So there is no anaerobic respiration being used for figure 1a. Answer C, the metabolic rate of the fish changed. Well, that's sort of the most correct answer at this stage. The metabolic rate of the fish would be expected to increase as it increases its speed. And D, the gas exchange occurred at organs other than the gills. Well, that's a little bit of a tricky answer because it might seem like that if you're reading that second paragraph in the stem and that sort of point number 2, and where it states that the oxygen uptake increases with temperature, blah, 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 because the fish puts more effort into flushing water past its gills. But you've got to remember to read the question, and that second paragraph is in relation to figure 1b. So that whole, all those 3 dot points, 1, 2, and 3, they are in relation to figure 1b and not figure 1a, which is what question 12 is asking us about. So for question 12, C is the correct answer. Question 13. According to figure 1a, which one of the following is the best estimate of how many milligrams of oxygen is taken up in 5 minutes by a 100 grams salmon swimming at 60 centimeters a second? So for figure 1a, where the speed equals 60 centimeters a second, the uptake of oxygen is about equal to 500. So therefore, the uptake of oxygen will be 500 times the weight, which in this case is 100 grams or 0.1 kilograms, times the time, which in this case is 5 minutes or 5 on 60 hours. So if you just sort of work that out quickly, what you get is 50 times 5 on 60, which is equal to 250 on 60, which is equal to 25 on 6, which is about equal to 4. So the correct answer for question 13 is B. The most important fact to know for question 14 is on the screen, that figure 1a describes the uptake of oxygen at various speeds for a temperature of 15 degrees. So if you take quickly a look at figure 1b, if we firstly look at line 3 and we set the temperature value for 15 degrees, you'll find that the uptake of oxygen value is 300. So what this means is that we can take this oxygen uptake value and go across to figure 1. And if we set our figure 1 oxygen uptake value for 300, you'll find that the speed is 40 centimeters a second. And this is the speed of line 3. So the reason why we can use the oxygen uptake value in figure 1b in figure 1a is that we've matched up the temperatures. So figure 1b is operating at the value of 300 is at 15 degrees, which is the value coincidentally that figure 1a is using for its temperature. So therefore we can say that line 3, the speed will be 40 centimeters a second, and therefore the answer is B. Which one of the following best helps to explain why for line 3 oxygen uptake at 20 degrees is greater than at 10 degrees? Compared with the case at 10 degrees, at 20 degrees, the fish swims faster, anaerobic respiration is greater, more energy is needed to achieve the TSS, and more energy is used for activities other than swimming. So Let's just go through each of the answers. A is not correct because the fish does not swim faster at 10 degrees versus 20 degrees if we're referring to line 3 in figure 1b. Line 3 is always at the same speed, so therefore this fish cannot swim faster. Anaerobic respiration is greater for B. Well, that is incorrect, as anaerobic respiration is only sort of activated when we reach the TSS, and line 3 never reaches the TSS. In fact, the only line to achieve TSS is line 5. And that is the line that is at the fastest speed, and has point M representing the TSS. So because lines 1, 2, 3, and 4 never achieve TSS, we can comfortably say that anaerobic respiration is not greater in 10 degrees than 20 for line 3. C, more energy is needed to achieve the TSS. Again, line 3 does not achieve TSS. So therefore, the only answer is D, that more energy is used for activities other than swimming at 20 degrees versus 10. So the correct answer for question 15 is D. Question 16. So question 16 is actually quite simple as long as you understand what Q10 is. So Q10 is the metabolic rate at X divided by the metabolic rate at a temperature 10 degrees less than X. So what we sort of want is we want our metabolic rate at X to be much larger than the metabolic rate at a temperature 10 degrees less than X to get the largest value of Q10. So where does that appear on line 5? Well, it sort of most clearly appears at point M, where the temperature is 15 degrees. We can see that the uptake of oxygen at 15 degrees is much larger than the uptake of oxygen at 5 degrees. So therefore the Q10 value is going to be greatest at M. So therefore the answer is B for question 16. If you want to confirm those values, you can just sub them in. But yeah, so the most important fact is just to sort of understand Q10, and that I guess the metabolic rate represents is another word, for the uptake of oxygen.